Hello, everybody. Welcome back to my 365 Days of Astronomy podcast. I'm Shaila Akhter, a PhD candidate in astronomy and astrophysics at the University of New South Wales, Australia. I am also a CSIRO Astronomy and Space Science co-supervised student. So, which recent event is tantalizing to you at the moment? Well, to me, it's New Horizons Flyover event. Yes, today I would like to talk about this. Previously known the ninth planet of our solar system, Pluto, is in fact a dwarf planet. It was the first discovered object beyond Neptune and its neighborhood, in the region named Kuiper Belt. It takes 248 Earth years to orbit our Sun. Due to Pluto's highly elliptical and inclined orbit around the Sun, the distance between Pluto and Sun can vary between 4.4 to 7.3 billion kilometers. And yes, this means periodically Pluto can become closer to our Sun than the planet Neptune. This might now raise a question. Do Pluto and Neptune collide with each other? The answer is no. Due to their orbital resonance, these two nearby planets will never collide. Such a relief, right? Pluto was discovered by a 23-year-old American astronomer Clyde William Tombaugh in 18 February 1930. It was originally considered as the ninth planet of our solar system. Later in 1992, due to the discovery of many other similar-sized Kuiper Belt objects, made the status of Pluto being a planet questionable. In 2005, another object in our solar system was discovered, named Eris, which is around 27% more massive than Pluto. This discovery led the International Astronomical Union, or IAU, to formally define the term planet for the first time. According to their new definition, Pluto lost its status as a planet and was reclassified as a dwarf planet. Poor Pluto. Though till today, Pluto is the largest and the second most massive dwarf planet in our solar system, whereas Eris is the second largest and the most massive dwarf planet. This dwarf planet Pluto has 5 moons orbiting around it: Charon, Nix, Kerberos, Styx, and Hydra. Do you know? Venetia Burney, an 11-year-old schoolgirl in Oxford, England, proposed the name of Pluto. She was very fond of classical mythology, and the name Pluto came from the god of the underworld. Pluto is relatively small. In comparison to our Moon, Pluto is 1/6 of its mass and 1/3 of its volume.
11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
NASA launched its New Horizons spacecraft on 2006, and after a 3,462-day journey across the solar system, New Horizons made its closest encounter on 14 July 2015. It provided us lots of images of Pluto and its satellite Charon. These are helping the scientists to characterize Pluto and Charon's geographical structures and understanding surface composition and the atmosphere. In compared to Earth, Pluto has a larger atmosphere. Why? Because gravity depends on the mass of the rock and Pluto has a smaller mass and radius in compared to Earth. So the gravity of Pluto is small too. This is why the atmospheric gas from Pluto can escape easily, making its atmosphere bigger than that of the Earth. On 13 July 2015, before the Pluto flyby event, New Horizons sent us this adorable picture of Pluto, where the astonishing brightest feature, the heart, is easily noticeable. This is also called the Tombo Regio, after the name of Pluto's discoverer. The left lobe of the heart is called Sputnik Planum, which was named after Sputnik, the first artificial satellite sent to space from Earth. New Horizons scientists combined 4 optical images from Long Range Reconnaissance Imager or LORRI with color images from the RAF instrument and created this beautiful enhanced color image of Pluto. The exaggerated colors in this image helps scientists to understand the compositional diversity and the age of many geological features of Pluto's surface, such as craters. These false colors also indicate that this geomorphological variety of the surface are caused by a great diversity of processing, such as space weather. Now look at the diversity we can identify in this false color image. The heart of the Pluto has 2 remarkably different colored regions: the peach-colored western lobe and the blue-colored northeastern and southwestern lobes. From middle to lower middle section, a band in shades from bluish to dark red. Again, we can see various yellow and orange shades in the northern polar region. These all indicate the compositional differences. The heart of the heart Sputnik Planum suggests a source region of ices from where ices might have transported away and made the blue northeastern and southwestern lobes. This is the methane ice plot of Pluto. The surface of Pluto mainly contains nitrogen ice, methane ice, and carbon monoxide ice. This is the first detailed image of Pluto from New Horizons' RAF instrument. In this image, scientists used 3 different wavelengths of infrared light, which are invisible to human eyes. The green band, as in the northern polar cap and in western zone, indicates regions where methane ice absorbs no light. That is, methane is diluted in a thick slab of nitrogen ice which absorbs infrared light. The blue represents the medium strong absorption and the red represents the strong absorption of light by methane ice. Again, this noticeable difference in methane abundance from place to place clearly indicates the compositional diversity of Pluto's surface. This image shows the carbon monoxide ice concentration on Sputnik Planum. With Pluto flyby, New Horizons revealed various geographical features on Pluto's surface: 2 icy mountain ranges and a flat icy plain in the heart of Pluto's surface. The 2 mountain ranges are named Norgay Montes and Hillary Montes, after Sir Edmund Hillary and Tenzing Norgay, who first summited Mount Everest in 1953. This is the first high-resolution image received from the New Horizon, which contains 1% of Pluto's surface. It is 150 miles or around 240 kilometers across the southern region of Tombo Regio. This reveals beautiful icy mountains of up to 3.5 kilometers height, informally named as the Norgay Montes. The most stunning fact here is that the first image of the Pluto flyby shows no crater in it. A second range of young icy mountains, named Hillary Montes, was discovered near the southwestern transition between Pluto's heart and the dark, heavily cratered zone. These mountains are up to 1 to 1.5 kilometers high, similar in height to the US Appalachian Mountains. The two icy mountain ranges are 110 kilometers apart from each other. Though Pluto's surface contains mainly nitrogen and methane ice, they are not strong enough to build the mountains. This is why NASA scientists are thinking that these mountains are made of water ice, which behave more like rocks at Pluto's temperature. The frozen plains in the left lobe of Pluto's heart, Sputnik Planum, resembles to frozen mud cracks on Earth and reveals many fascinating features. Though the surface looks absolutely plain from a bit distant, a close-up look features some almost 20 kilometers across irregular shaped segments, surrounded by shallow troughs. Some of these troughs contain groups of hills and others contain some darker materials within them. These irregular segments might have formed due to the contraction of surface materials, just like when the mud dries on Earth. A second reason could be the convection of heat from Pluto's warmer interior to its frozen icy region. Other than the irregular segments and troughs, there are also some pitted surfaces found on the Sputnik Planum, which are thought to be built upon the direct evaporation from solid ice to gas, such as dry ice on Earth. The icy plains also shows some dark streaks aligned in the same direction. These are few miles long and might have generated due to the ice flow and may still be flowing, similar to glaciers on our Earth. The absence of craters in the Tombaugh region means this is a very young surface, because Pluto could have been bombarded for billions of years by other objects in the Kuiper Belt if it was that old. NASA scientists are thinking that this region might be geologically active now and could be possibly less than 100 million years old, which is a small fraction of the 4.5 billion years age of our solar system. This is the youngest known region in our solar system. On the other hand, the dark, heavily cratered regions next to Tombaugh region are maybe billions of years old. Scientists are anticipating that a complex interaction going on between these young and old regions. There must be some physical process going on to keep Pluto's surface young at various regions. The scientists are still intrigued and looking forward to solve this mystery. This amazing halo of Pluto's silhouette, backlit by the sun, is the signature of New Horizons to embrace a farewell to Pluto on 15 July around midnight Eastern Daylight Time, 2 million kilometers away from Pluto. At the same time, it marks humanity's success to pass by Pluto and explore beyond. The scientific observations of Pluto started on February this year and will continue until mid-August. So, we are still awaiting for more stunning discoveries shortly. That's all for today. I'll definitely come with more stories in future. Thanks for listening to me. Take care and goodbye.